Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on January 29, 2026, about 5 days ago. It introduces a new training paradigm that enables multimodal models to perform extensive deep research, achieving a 16-point improvement over baselines and outperforming closed-source giants like GPT-5. The paper is titled, Vision-DeepResearch, Incentivizing Deep Research Capability in Multimodal Large Language Models. And as we'll see later, the way it handles visual noise in search engines is a real game changer for complex queries. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 maps out the core motivation and results. Panel A on the left identifies the hit rate problem, showing that standard full image searches often fail to retrieve evidence, whereas cropping to specific objects works much better. The charts below that contrast reasoning depth, where the new method, in yellow, executes far more search rounds than competitors like Gemini. Panel B on the right then outlines the solution, a pipeline that combines multi-scale visual search with long horizon training. Finally, the bottom graphs confirm the impact, showing the model surpassing GPT-5 and Claude 4 across 6 different benchmarks. Well, Figure 2 breaks down the comprehensive data pipeline used to train this system. The top panel illustrates the trajectory generation process. Here, the model crops specific entities, like these basketball players, to perform targeted searches, which significantly improves the hit rate compared to searching a whole noisy image. Next, the middle panel introduces text bridging. This converts visual discoveries into text descriptions, enabling a powerful text-only model to plan long-horizon reasoning steps. Finally, the bottom panel displays the question synthesis, where they generate complex, multi-hop queries to ensure the model learns robust research skills. So, having established the pipeline, Table 1 presents the main benchmark results across 6 tasks. The top sections show baselines like direct answer and standard agent workflows, where models like GPT-5 and Gemini 2.5 Pro perform decently but hit a ceiling. However, looking at the bottom section, the Vision-DeepResearch model achieves a massive leap. Specifically, the 30 billion parameter model posts an average improvement of 16 points over the base agent, effectively outperforming the closed-source giants. Alright, while the main benchmarks set the stage, Table 2 and Table 3 here dissect exactly why the method works. First, Table 2 tests the rollout strategy. The key comparison is between WIS plus TS, meaning whole image search with text search, and the final row, CIS plus TS, which uses cropped images. The score leaps from about 29 to 40, proving that zooming in on specific visual details is essential. Then, Table 3 tracks the training progress. It shows that adding 6,000 fuzzy versus QA trajectories creates a strong foundation, which the final reinforcement learning stage then polishes to reach the top performance. Well, Figure 3 visualizes the dynamics of this reinforcement learning stage. On the left, the graph tracks the average trajectory length, which steadily drops from around 14,000 to 8,000. This indicates the model is becoming more efficient, cutting out unnecessary steps to reach the solution faster. Then, looking at the right panel, we see the corresponding reward score. While the dark blue line is noisy, the lighter smooth line clearly trends upward, confirming that as the model gets faster, it also gets more accurate. So, Figure 4 walks through an actual long horizon trajectory to illustrate this process. Starting with the lecture image in the top right, the model tries to find the date, but its initial attempts hit a wall. In rounds 1 through 3, neither face crops nor general searches return useful evidence. Success only comes in round 14, where a wider crop identifies the speaker, Dr. Caroline Robertson. This breakthrough enables the model to verify the location and finally pinpoint the correct date in round 25. Wrapping up, 2 takeaways stand out. Effective multimodal research requires zooming in to solve the visual hit rate problem, rather than relying on noisy full image searches. Furthermore, combining this granular retrieval with long horizon reinforcement learning allows these models to outperform even the strongest closed source systems. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.